Hello everybody, it's Mr. Joseph again. Today we're going to focus on multiplying polynomials, but before we multiply polynomials, it's really important that we understand the difference between adding terms and multiplying terms, because this is a mistake I see over and over again. So for instance, the first question is, what's x plus x? We learned before when we're adding and subtracting that we can only add and subtract like terms. So when I see x plus x, I'm just like, oh, I have 2x. However, when we do x times x, that's different. We have to remember our exponent rules that said that if we have the same base, that we add the powers. So x times x ends up being x squared. And as we keep going, 2x plus 3x, both the same terms, both have an x, so I have 5x in total. However, when I do 2x times 3x, I know that 2 times 3 is just 6, and x times x is x squared, based on what we said earlier. Next example is 2x plus 3x squared. I will put a sad face because there's nothing that we can do. Both of these are different terms. 2x plus 3x squared just equals 2x plus 3x squared. It's the same exact thing because there's nothing else we can do to simplify this problem. But on the one to the right, we have 2x times 3x squared. Once again, 2 times 3 is 6. X times x squared is x cubed, because don't forget, there's that little 1 there, and if we add the exponents, we get a 3. So that's the first thing that you need to understand before we start actually multiplying polynomials. Next, we're going to move on to multiplying polynomials. And the first thing that you need to understand is whatever your first term is, it's going to multiply everything to the right of it in our new parentheses. So that's why you're going to see me do x times x times -5. Once again, we are multiplying here. So that's why I'm going to get x squared, x times -5. Oh, that's just minus 5x. Then I'm going to erase these. Oops. Let's see. I was good at this. And now we're going to focus on our second term. And our second term is also going to multiply everything to the right. And 2 times x is the positive 2x. 2 times -5 is minus 10. So I am showing you that intentionally because I didn't want to mess with the arrows and make it look really messy. A shortcut that you could do to show the arrows in a more efficient way is you'll see this. You'll see bam, bang, under, under. So that's another way that you might see it, and you could have all the arrows at once instead of, writing them separately like I did. And then we see here that we are adding and subtracting now, so we find like terms. The two middle terms are like terms, and we get x squared minus 3x minus 10, and we are done with that. So that's how you do the first one. Now we're going to move on to example 2, and I'm going to erase this so I have room for my arrows. And if you remembered from my other example, I said we're going to take our first term and we're going to multiply everything to the right, and we are going to get, oh, before I just say the answer, remember, this is when you need to know your exponent rules, because here we're doing 3x times x squared, which is 3x cubed, 3x times minus x, which is minus 3x squared, 3x times 5, which is a positive 15x. Then I'm going to take my second term and multiply everything to the right as well. We get -4 times x squared, which is -4x squared, -4 times -x, which is a positive 4x, and -4 times 5, which is a -20. Now we get to highlight, which is so fun. We get to, oh, nope, X cubed only has one thing, so I'm done using that color. On to the next color. I'm going to highlight all my square terms, and then my X terms, and then my polar constant by itself. We don't really have to highlight it, but we just want to make the term feel like it's included. And then I'm going to use black for my final answer. I'm going to have 3x cubed minus 3x squared minus 4x squared. That is minus 7x squared. So we're becoming more negative. Then we have 15x plus 4x, which gives us our 19x. And then we just had that negative 20 at the end by itself. And that's how you do an example of a binomial times a trinomial. So our next section is fill in the blank. So this is kind of another way to visualize this distributive property that's going on. So when I look at this problem, I kind of look for truths. So I know the two numbers right here need to multiply. It's 18. So to me, this is not going to be a difficult problem because there's only 6 times 3. And that works. That 6 times 3 is 18. But also, if I want to make sure that the middle term works, that I am getting a plus 9 in the middle, if I do 6 plus 3, I also get a 9. So both checks worked here. And of course, that x times x gives me that x squared. When we get to the next problem, which is x squared minus 36, this is a little unique. I'm missing something. So what the question that you have to ask yourself is, when you're missing that term in the middle, which is like that, the equivalent to that 9, I don't know if you realize, but like this problem has a 9. This problem is missing that term in the middle. So that means that when we add the two terms together, it needs to get me a 0. But these same two numbers need to multiply to give me negative 36. So there's no choice but for the numbers to be exactly the same. So what same two numbers multiply to 36? Well, that's 6 and 6. And 6 minus 6 also gives us that 0. But if you're not convinced, that's okay. All we do is we write out our answer, and we are going to distribute and check. X times x is x squared. X times negative 6 is negative 6x. 6 times x is positive 6x. 6 times negative 6 is minus 36. Highlight our middle terms, which will give us 0. And we end up with x squared minus 36. So we are all good. I hope that helps. Have a great day.